Hello students, let us continue with the chemical properties of ethers. The first set of reactions are those involving cleavage of carbon-oxygen bond of ethers. The example taken is reaction with hydrogen halides. As you all know, the general formula for hydrogen halides is HX. Now, the cleavage of carbon-oxygen bond in ethers will take place under strong reaction conditions. The product formed will be an alcohol. If we just look there, ROR dash plus HX, which is the hydrogen halide. R dash picks up the halogen to form the byproduct R dash X, and you will get the main product as the alkoxide group RO minus, picking up the proton forming alcohol ROH. So you will get the product as an alcohol and an alkyl halide. Suppose the reaction of dialkyl ether takes place, that is both groups R and R are alkyl. So dialkyl ethers will react with excess of hydrogen halides. 2 molecules of hydrogen halide is taken here. So they react with excess of hydrogen halides and you will get the product as an alkyl halide. That is, both the carbon-oxygen bonds are cleaved and the 2 halides are picked up so as to get 2 RX as the product with the elimination of water. An interesting reaction is that of aryl alkyl ethers. Now the general representation of an aryl alkyl ether is given by a phenyl group, oxygen functional group and an alkyl group. If you look to this structure, now RO is nothing but the alkyl oxygen bond, and here the oxygen forming the bond with the carbon of the aromatic ring is the aryl oxygen bond. Of the two, the aryl oxygen bond is more stronger, whereas the alkyl oxygen bond is a weaker bond. Because of this stable aryl oxygen bond, the alkyl oxygen bond is cleaved so that you will get the phenoxide ion C6H5O minus, and in the presence of the hydrogen halide HX, C6H5O minus phenoxide ion will pick up the proton so as to form the product as phenol, and you will get the byproduct as RX. So the byproduct formed is RX. So these are the different reactions with the hydrogen halides wherein the carbon-oxygen bond is cleaved. The first set of reactions. The second set of reactions are electrophilic substitution reactions. Now, for electrophilic substitution reactions, as you all know, we need to consider an aromatic ether. The example of the aromatic ether taken here is methoxybenzene or anisole. The popular common name of methoxybenzene, C6H5OCH3, is anisole. And the first electrophilic substitution reaction is halogenation reaction. Now, before going to the details of halogenation reaction, you need to know that the alkoxy group, now this will be the alkoxy group. The alkoxy group of aromatic ethers is an electron releasing group. It is an electron releasing group and therefore activates the benzene ring towards electrophilic substitution towards the ortho and para positions. Hence it is ortho-para directing group. Therefore you will get a mixture of ortho and para products. Now coming to the first electrophilic substitution reaction, halogenation. In particular, I will take the example of bromination. Now anisole is heated with bromine in acetic acid. As you all know, bromine is a reddish brown colored gas. Acetic acid formula is CH3COOH. So anisole on heating with bromine in acetic acid, you will get a mixture of ortho and para-bromoanisole. That is, ortho hydrogen of one anisole molecule will be replaced by bromine and the para-hydrogen of the other anisole molecule will be replaced by bromine. So this is ortho-bromo-anisole. Ortho-hydrogen is replaced by bromine, and this is para-bromo-anisole plus 2HBr. Now of the two ortho and para products, always the para product will be a major product. Incoming group is far away from the already present group at the aromatic ring. So therefore para-bromo-anisole is obtained as a major product. So anisole reacts with bromine in acetic acid on heating to give a mixture of ortho and para-bromo-anisole. 2HBr is eliminated as the byproduct. So this is regarding halogenation, in particular bromination reaction of anisole. Now coming to the next electrophilic substitution reaction, that is nitration. As you all know, students, for nitration we require nitrating mixture. What is a nitrating mixture? A mixture of concentrated HNO3 and concentrated H2SO4. So HNO3 can also be written as HONO2, both are same. So that mixture is called as a nitrating mixture. Let us look into the details of nitration reaction of anisole. Now just look there. Anisole reacts with a mixture of concentrated nitric acid and concentrated sulfuric acid, that is nothing but a nitrating mixture. If you look there are two molecules of anisole. With one molecule, nitro group is introduced at the ortho position and you will get the ortho product, which is nothing but ortho-nitroanisole, or if you use the locant or number, it is 2-nitroanisole. With the other molecule of anisole, nitro group enters the para position. This is the para position, so that you will get the product as para-nitroanisole, or if you use the locant, it is 4-nitroanisole. Once again, the para product will be obtained as the major product, whereas the ortho product will be the minor product with the elimination of two molecules of water. Now I would like to remind you that these reaction equations have to be written and rewritten. Practice them thoroughly so that you can remember. You cannot just remember them for a longer time by reading the reaction equations. You need to write them and practice so that you will remember it for a longer duration. Now, the next electrophilic substitution reaction is a named reaction which you have already studied, that is Friedel-Crafts reaction. Last year you have studied with Friedel-Crafts reaction of benzene. Now here we will be discussing with the Friedel-Crafts reaction of anisole or methoxybenzene. Two reactions are there in this. One is alkylation and the other is acylation. Simple. The definition for alkylation is introduction of an alkyl group into the aromatic ring will be alkylation, and in introduction of an acyl group into the aromatic ring will be acylation reaction. The group R is called as alkyl group and the group RCO is called as the acyl group. So alkyl group will be represented by group R, whereas the acyl group is represented by RCO. Now this will be the acyl group. Yes. So coming to the details of alkylation reaction, anisole reacts with methyl chloride CH3Cl. The alkyl group is methyl group here. So anisole reacts with methyl chloride in the presence of anhydrous aluminium chloride AlCl3 as catalyst to give a mixture of, just look here, 2-methyl anisole and 4-methyl anisole. Now with one molecule of anisole, methyl group is introduced at the ortho position. With the second molecule, methyl group is introduced at the para position. So this is 2-methyl anisole and 4-methyl anisole if you use the locant, with the elimination of 2HCl as the byproduct. So alkyl group is introduced into the aromatic ring, therefore it is called as Friedel-Crafts alkylation reaction. Now next is acylation reaction. If you compare this, yes, CH3CO is taken here. Acetyl group is taken as an example. In general, I have said that the acyl group is represented as RCO group. Now, anisole reacts with CH3COCl is called as, this is called as acetyl chloride. CH3CO, if there was OH here, it is called as acetic acid. That OH is replaced by Cl. So therefore CH3COCl will be called as acetyl chloride. And if you want the other IUPAC name for this, it is also called as ethanoyl chloride. Ethanoyl chloride is the IUPAC name. Both are correct. So anisole reacts with acetyl chloride or ethanoyl chloride in the presence of, once again, anhydrous aluminum chloride catalyst to give a mixture of, just look to the product here, it is an aromatic ketone. You can name it as 2-methoxyacetophenone. C6H5COCH3 is the aromatic ketone, acetophenone. At the ortho position or the second position, there is the methoxy group. Therefore, it is orthomethoxyacetophenone or 2-methoxyacetophenone, and the other product will be 4-methoxyacetophenone or paramethoxyacetophenone. Once again, of the two products, major product will be 4-methoxyacetophenone. So acetophenone is an aromatic ketone, COCH3, wherein it is bonded to the aryl group or benzene ring. So this is Friedel-Crafts acylation reaction of anisole. Both the reactions are equally important. Friedel-Crafts alkylation as well as Friedel-Crafts acylation reaction of anisole or methoxybenzene. So these are the different chemical properties of ethers. End of the topic, ethers. I hope students the topic is clear. And once again, I will be giving the assignment questions for this topic, ethers. Try to write the answers. To remind you once again, write the reaction equations repeatedly and practice them, so that you will not forget the reaction equations. I hope by now you have written the assignment questions for haloalkanes, haloarenes, alcohols, phenols, and now it will be ethers. So I will continue in the next class with another set of organic compounds, that is aldehydes, ketones and carboxylic acids. So in that we'll begin with aldehydes in the next class. I will be stopping here. Thank you.